Here is another simple simulation that can be used to help the students visualize the concept of principle of superposition. So here, when I click on this button, you can see the first pulse on the left-hand side, which is going to travel towards right-hand side. Then here I click and you see the second pulse, which is on the right-hand side, but which is going to propagate towards left-hand side. And I click play here and you see both the pulses traveling towards each other. They overlap and they continue their journey. So just at the instance of overlap, we can see that the resultant amplitude becomes twice the amplitude of either of the pulses. So I'll just pause it here and I'll animate it so that that will be clear for our visualization. You see, each pulse is having a height of, let us say, 3 units on this graph paper. And we see that as the wave propagates, at this point, if I allow them to increase by clicking this plus, 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 and you see the resultant has become twice. So 1, 2, 3, 4, 5, and up to 6. And what happens after they superimpose with each other? Nothing. They just continue the journey as it is. And that is the very basic of principle of superposition. It means that the fundamental nature of the superposing pulses, that is not changed. They just continue to propagate as if nothing has happened. And that is the very essence of principle of superposition. Of course, in order to plot these things, these arrows, I have used the Zoom interface because I like Zoom a lot. This gives me the liberty of screen sharing and annotation while using the screen share without having to download any other tool. So I'm using that. So I'll clear the annotations. Now we will pause it. And because presently, when the pulses overlap, it looks like they are colliding and they are turning back, but it's not the case. And in order to help the students visualize that, we will increase the amplitude of one of the pulses and decrease the amplitude of the other pulses and then let them superimpose. Now it will be clear to the students that yes, they overlap and the journey continues. Right? Then furthermore, we can keep the amplitude of one of the pulses at plus 40 and we will decrease the other one to negative. And we'll see what happens when the pulses superimpose each other. And there we see, yes, for a moment they vanish and still they continue the journey after that. Now, the fact that they vanish for a moment may not be clear if we just run the simulation like this. So I will pause it just a moment before they are about to overlap each other and then move it step by step, what in physics we call as delta t or dt, small increment in time. And you see that the pulses, while they are overlapping, they cancel out each other. But since their propagation continues, they again rise and they continue the journey like this. Step by step, they continue the journey like this, which is clearly seen in this simulation. That is how they continue the journey. So this is how I use this simulations in my class to enhance the visualization. And I found it personally very satisfying after the simulation was ready. So if anyone wants to use this, it is there on my website. It is free for anyone to use, the students, the teachers, anyone. And if you have liked it after using it, at least drop me a message, drop me a mail. That will keep me motivated to carry on the work like this. Thank you, everyone.